All right, let's jump into it. Let's talk about these sequences. So here we be. Here's our definition of a sequence. A sequence, as we've talked about before, we write the little curly brace around some a sub n, where n is our index telling us what term we are on, right? We got our terms. It's just a list of numbers or terms. A sub 1, 2, 3, 4, 5, 6, 7, all the way up to n, and they can keep going forever. We're calling n is our index while they switch the numbers up, or the letters up. No big deal. We got this. A sequence may be generated by a recurrence relation. So we're saying where we got some a sub n plus 1, and then maybe you have, like, what was our previous example? Like, it was 2 plus a sub n. That's our f of. It's saying you got some nonsense with some a sub n in there. So we had 2 plus the term from before. Or 3 plus, or whatever the heck the problem was we've done before. Sorry, I've made a lot of videos. Harder for me to remember. And the sequence may also be defined with an explicit formula. So we want to know the two things. Recurrence means you got to use the term from before. And an explicit formula means you can just plug in an n. There's no using the term from before. All right. So what we're going to do here is we want to use an explicit formula. Not the recurrence. We're going to use an explicit formula. An explicit formula. So we can write it in the form for a sub n. Sorry, my curly braces suck. I'm actually doing pretty well. Now, you might see it written like this, which means we're going to want to write out every term. I don't write that. It's implied that that's there. So, but we're going to start at 1. So all we want to do to write the first 4 terms. Okay, so we're gonna give you something, and then we're gonna write out the first 4 terms. No biggie. I'm gonna start at Mel, and I'm using directly from your textbook. So if you want to open up the e-text, check it out. I'm using the exact problems right now. Figure, why am I gonna make up new ones when students don't read it anyway? I'm not gonna reinvent the wheel. So we're like, bang! There is an explicit formula. You can tell it's explicit, not recurrence. Because it doesn't tell you anything about a sub n minus 1. It just tells you, plug in freaking n. You're going to get some numbers. No big deal. Let's go. So, let's just start. I'll write it out kind of easily. N equals 1. N equals 2. N equals 3. N equals 4. All right. So, here we go. A sub 1 is equal to 1 over 2 to the first. Get it? To get it, a sub 2 is equal to, and please don't write it out like this. I'm just writing it out the long way to try and make it look a little simpler. A sub 3 is equal to 1 over 2 to the third. So we're just changing the frickin' exponent. This is no big deal. We're just changing the exponent from 1 to 2 to 3 to 4. And there we have it. So we wouldn't write it like that. We'd write it inside the sequence. So we have 1 over 2 to the first. First. That's 1 over 2. Now we go to 2. We have 1 over 2 squared. That's 1 to the fourth. For the third term, we have 1 over 2 cubed. That's 1 over 8. Then we have our fourth term, which is 1 over 2 to the fourth, which is 1 over 16. And then it just keeps going on forever and ever. There we go. There's a sequence. We created one. See, it's not that bad. We just got to know where things go. Once we know where things go, we're all good. Now, if I was to plot this on a graph, because this is going to be a big game, where let's make this the n axis, and up here is your a sub n axis. Just think of n as x. Think of a sub n. These are all our a sub n's right here. These are our a sub n's. So we could think of these as like our y values, huh? And then we'll think of our x values. They're not x's, they're n's. As the first term, the second term, the third term, and the fourth term. So let's just kind of plot those things out where we have like 1, 2, 3, 4. So our first term that we had was 1/2. So I'll put in a 1/2 right here. There's our first one. There it is. There's our dot. And then we go to 2, and then we're down to a 4th, huh? We're getting half as close. Oh, we're getting even. Oops. Color code, dum-dum. Come on, dum-dum. You can do it. Color code. There we go. And then we get half of 1/4, which is 1/8. We get to our third term. So, we're getting closer. So here we go. Now, oh, shoot. And then the next one goes to 1/16. I'm running out of room to write it, but I think there's 1/16s right in there. And do you see that the dots are just going to do this? They're going to get closer and closer to 0. I'm going to write something else to the side. The limit as n goes to infinity of our little a sub n. It looks like it's going to 0. Right? We put in infinitely many. We're going halfway to the door, halfway to the door, halfway to the door, halfway to the door. We're getting closer and closer to the door, but we never touch the door. But where are we going? We're going to the door. 0! 0. So that was just a little lead in. But hey, for now, can you plot the frickin' points? Can you come up with some sort of sum? Let's do another. Sum. Ooh, I misspoke. Sequence. So let's do another one. We're going to write the first 4 terms. Now this is going to be a big one. -1 to the n. Oh my goodness, you're going to see that a lot. Times n over n squared plus 1. This is no biggie. This is no biggie. This is no biggie. Now I want to just talk about this. Just this part here first. Because this is going to pop up over and over and over and over and over and over and over. This is what we're going to call an oscillation. What? Oscillation? Huh? Well, let's think about this. A sub 1, when we plug it in, you get -1 to the first. Isn't that -1? I'm not writing in the rest of it. Just for that part. And if you get -1 squared, isn't that +1? And if you have a cubed, wouldn't you have -1 cubed? Isn't that -1? And then you have a to the 4. Can I stop writing this now? Do you see that it just goes from negative, positive, negative, positive, negative, positive? So if you have -1 to the n, the odd terms are negative. The even terms are positive. Shoot, if we wrote -1 to the n plus 1, then it would flip-flop. But let's just start here. So I only talked about the -1. So we're going to see that the terms will change sign from evens and odds. But this time, let's write it out again. So we're going to write some a sub 1. We're going to be like, cool. -1 to the first times 1 over 1 squared plus 1. Neat. Now let's go to our second. -1 squared times 2 over 2 squared plus 1. Actually, I'll just go right here. A sub 3 will be -1 cubed times 3 over 3 squared plus 1. And lastly, -1 to the 4th times 4 over 4 squared plus 1. So all we're doing is starting at 1 and replacing our n's. Then going to 2, then going to 3, then going to 4. So this is going to be -1 times 1. That's -1. Over 1 squared plus 1, that's -1/2. Therefore, a sub 1 is -1/2. Next, we're going to go and we have -1 squared. That's positive. So we get a 2 up top. Now we have 2 squared, which is 4 plus 1 more, which is 5. So a sub 2 is 2/5. But notice the first term was positive. The first term was negative. The second term was positive. I'm going to guess this third term is going to be negative because it's being raised to an odd power. So -1 to the third is negative. And then we got a 3 up top. 3 squared is 9, plus 1 more is 10. And there is our third term. Lastly, let's do our fourth term. Let's be done with this part, and then we'll move on to something new. -1 to the 4th, that's an even power, so that's going to be positive. So we end up with a 4 up top. 4 squared is 16, plus 1 more is a big old 17. So we have a sub 4 is equal to 4 over 17. So let's write our explicit list for our sequence. We have -1/2, comma 2/5, comma -3/10, comma 4 over 17. There we go. And then I'm just going to pop up just a quick little thing. It's going to go on, and we write the ... saying we're going to go forever and ever and ever. And I know these numbers aren't quite as simple to see, but I just want to plot one out. Sorry, these videos are so long. Where we got our n-axis, 1, 2, 3, 4, 5. This is n. This is our a sub n. So our a sub 1 was what? -1/2. So I'll put a dot down here. At 2, we had 2/5. 2/5, do you know 2/5 is about 0.4? It's actually not about 0.4. It is 0.4, which is smaller than a half. So it's a little closer to the axis. A sub 3, that was -3/10. That's even a little closer to the axis. And then we pop in our next one, we get 4/17. That's actually closer. And if we kept playing this game the whole way through, the dots are just going to be on either side of that n-axis, getting closer and closer and closer. They're just going above the axis, below, above, below. But they're getting closer and closer to the axis. These distances here are getting smaller as we go. Just smaller and smaller and smaller. They're getting closer. It looks like if you took the limit as n tends towards infinity of this sum, it looks like it's going towards 0. We're going to do a lot of that. So, all right, that was way too much. First 2 videos, they've both gone over 10 minutes. Let's make sure that we have shorter videos in the future. All right, see you soon.